Hi everyone, in this video we're going to discuss UPS questions. For question 1, if set A is given a list of numbers here, so we identify the categories of the number, so 6 over 13 is a rational number. We can see this one, 2.31, then we have a bar here means 2.313131, so it have a repeating decimal, so this is also a rational. Then negative 8 is a integers, and then it's a rational, it's a real number. And then square root 169 it is equals to 13. So 13, it will be a natural number, a whole number, integers, rational, and real number. So 24. 24 also same like 13, natural number, whole number, integers, rational, and real number. And we come to these decimal numbers, we can see the decimal here is not in the pattern, means this one is irrational number. So which of the following set is false? For natural number, it is square root of 169 and 24. This is true. For rational number, which is Q, it is equal to 6 over 13, yes. The repeating decimal, yes. The negative integers, yes. So negative integer is a subset for rational number. Then the square root of 169, yes. And then the number of 24, also yes. So this is true. Then we go for this. Negative 8 is an integers, yes. But this one is not. This is rational. So this is integer, positive integer. This is positive integers, so yes. So our option will be this option where this is false. So come to irrational number, we have a decimal number that the decimal here is not in the pattern, so this is true. Next, we're going to see this interval for A and B and C. All these x are real number. We're going to intersect and union. So first of all, we're going to intersect this. So simplify this interval first. Divide by 2, it will be negative 7 and equal to 5. So negative 7 is not included, 5 is included. Then we come to set B, negative 2 and 7. So negative 2 included, 7 not included. So first of all, we find the intersection first. The intersection will be the overlapping for these two number lines. So it happened at here, which is A intersect B will give you negative 2 included, 5 included. Then we union together with number line C. So number line C is negative 4 until 4. So negative 2 until 5, this is our A intersect B. So where C is x less than negative 4 and x more than 4, then when we want to union it, we will combine every number line here. So here we have less than negative 4, and then start negative 2, we combine up to, so after 5 also we still can combine. Therefore our answer will be x less than negative 4, x more than equal negative 2. And then write the answer in interval form. So our answer, writing in interval form, although this is our answer, but this is set notation, so we're not going to select it. So interval form only have x less than negative 4 and more than negative 2 included. So this is interval form. So here we have our option. Next, which is rational number? Rational number, which is Q. Q is involving the number which is in fraction and decimal. So decimal with pattern, whether it is repeat or it is terminating. So pi decimal is not repeat or terminating, but 3 over 8, yes. And then square root 45, as we can see, the decimal also not repeating or terminating. Square root 2 also not. So therefore, rational number 4 on 3 over 8. Next, what is the conjugate? So conjugates of this complex number. Simplify this complex number. So I power of 4, it is equals to 1. I power of 3, it is negative I. So as we write it, it will become negative q minus pi. So the conjugate of it, we're going to change the imaginary part to become negative q plus pi. So here we have our option. Then find the complex number given that modulus z is 12, then argument is negative pi over 6. As we can see, our argument is negative pi over 6, means the quadrant involving negative argument will be quadrant 4 and quadrant 3. So, and then we see the argument angle here, it is acute angle. When we have acute angle, means it will be fall on quadrant 4. Because quadrant 3, you need to open more than 90 degrees. It's supposed to have obtuse angle. So pick the complex number which having quadrant 4. So positive, negative, this might be our answer. This one negative, negative, quadrant 3 will not be our answer. This is positive and negative, this is quadrant 4. The positive, negative, this is quadrant 4. Then what we need to do is we're going to double check the modulus and the argument here. So we can use our calculator. First of all, we set our calculator mode to complex number. Then we type our complex number here, 6 square root of 3, and then minus 6i. Then we put in our option. So find your option. So I put for number 3 so that we can see the modulus together with this argument. So you can see 30 here because I'm using degree. So our calculator mode need to set to be angle units, which is radian. So the question A is correct. So this option is correct, which is 12 and argument negative pi over 6. Then the rest of it, we also need to try and see. So for the next complex number, it will be square root 3 over 2 minus 1 over 2i. So looks like is modulus does not fix here. Then the next complex number, 3 minus 3i. So argument is fixed, but modulus does not fix. So here we have our option. If p and q are real numbers, and 4p plus I 8q minus I equals to negative 11 minus 16i, find the value of p and q. First, we rearrange our unknown here in standard form as we expand. We have this, then we can compare. So simplify this I square. I square is negative 1. Negative, negative become positive 1. This is real part and this is imaginary part. So as a compare, real part 4p plus 1 equals to negative 11. P equals to negative 12 over 4, which is negative 3. Then imaginary part 8q is equals to negative 16. So q is equals to negative 2. So here we have our option. So given these indices equals to this, find the value of p and q. So let's simplify these indices power and power. Here we have x to the power of negative 4, y will power of negative q, then denominator x will power of negative p, y will power of negative 5, as all of it power of negative 1. So each of them need to power negative. And we can simplify here as we can see x divided by x, y divided by y. So for x, negative 4 minus negative p become positive. For y, negative q minus negative 5 become positive. Here we have x is power of negative 5, y is power of 2. As we compare here the power, negative 4 plus p equals negative 5. So p will equal to negative 1. Then as we compare the power of y, negative q plus 5 equals to 2. Negative q will be equals to negative 3. Q will be equals to 3. So here we have our option. Then which of the following laws of the logarithm can be expressed for this log expression as a single logarithm? So first of all, we can see this log is having the coefficient here. So we can move up. So when we move up, it will be fulfill this law. Any item that in power, it can be moved to the front as a coefficient, and at the same time, it can move up to be a power. So this is the properties that we also are going to use. And then log with log, plus and minus, we can make it to be a single logarithm. So log plus log, the item will be in multiply. So log minus log, the item will be in division. So log divided by log, it cannot be simplified, get 1 log here. So the rules here, the law of logarithm that will hold is 1 and 3. So here we have our option. Determine the correct step to solve this. So when we have square root, we rearrange our square root, let the square root one at left hand side, the others we move to the right hand side. So to remove our square root, we're going to square both sides. So 4 square give us 16, square root and square, we cancel each other, and we expand this, we get 4, and then 4x plus x squared. So we have a quadratic, we need to rearrange. So move the 16 to the right hand side, minus 16, you will get negative 12x plus 4 equals to 0. So looks like we have the step here. So here we are, our option. Then for this question, it is a rational inequalities. First of all, we make sure the right hand side is 0. So this is less than 0. Then to solve this, we use positive number line. We will let numerator more than equal 0, but denominator cannot take equal to 0, so it only can make it more than 0. So we let our numerator positive, denominator positive, so our method is using positive number line. So x here will be more than equal negative 30 over 5, x more than equal negative 6, so x here more than negative 4. Here we draw our positive number line, start with negative 6 and negative 4, two numbers, three region. So equal to negative 6, more than that, the region with line is positive, the region without line is negative. Then more than negative 4, not equal, so positive, negative, negative, so positive. Multiply this, we get negative, then positive. Lastly, the region that we want to select is less than 0, means negative. So negative 6 is included, but negative 4 is not included. So therefore, we have this option. Next, for this question, as we can see, our inequality only have simple x, 1x. So we try to simplify this, time with 3, no need to change sign. Then move out the 5. When we move out the 5, we will minus 5. Then we divide by negative. When you divide by negative, we need to change sign. So here we come 35 over 2. Here we have negative 13 over 2. But in interval, we cannot write the bigger value at left hand side, smaller value at right hand side. So we have to rewrite this, follow the orders, start with smaller value. Then the sign is point on this negative. So the sign is point on the negative x. Then continue, this is 35 over 2. So here we have our option. Next, what is the solution for this? So we expand. As we can see at the right hand side already 0. Here we expand our quadratic. So you will get 4x. You can see our factorization is not start with x. So our quadratic haven't simplified yet. So 4x plus 8 minus x squared. Then minus 2x less than 0. So it is a negative quadratic. When we have a negative quadratic, we're going to simplify it. Divide by negative, then we need to change sign. After that, only we simplify by factorize. So we're having the roots of negative 2 and 4. Then we look at the region that we want. That is more than 0, so it will be above x-axis. So this region is x less than equal negative 2, x more than equal 4. So here we have. So this question trick you by using a negative factorization on your quadratic. Next, solve these inequalities. So for both side modulus, we're going to square both sides. First of all, we write the modulus in square root and square. Then to remove the square root, we're going to square both sides. So remaining term here is x plus 3 square more than x minus 1 square. We expand this as we can get a quadratic. Then we rearrange. As we move our x square, it simplified. Then remaining 8x. So linear, we move back the value to the right hand side. So divide by 8, no need to change sign. So x will be more than negative 1, so negative 1 to infinity. Therefore, we have this option. Then which statement are true for the modulus less than? So always remember, modulus inequalities, we have definition bigger than using or, less than using and. So when I want to define this modulus means when I want to open this modulus less than, I need to use definition and then insert the negative, change sign for another side here. So first of all, we can see definition or it is wrong. Definition and yes, it is true, and then one side is positive, one side insert negative, change sign, so number 2 is true. Then we try to simplify here. So 8 over 2 x less than 4. So divide by 2 x more than 1. So this is true, our solution. Therefore, we have 2 and 4. And then what is the value of the x where this function is undefined? So this function given here is a rational function when it will be undefined when its denominator equals to 0. So x equals to -1. So for x equals to -1, it can make this rational inequalities undefined. Next, which of the following statement are true about arithmetic? Arithmetic having common difference. So a is -half. Common difference, we take the term behind minus the term before that. So it gives us 5 over 2. So the value of common difference is 5 over 2. Yes, correct. The fourth term, then we need to calculate. So this one, they plus 5 over 2, they plus 5 over 2, we can plus 5 over 2, 9 over 2 plus 5 over 2, 14 over 2, it is 7. So this is not the fourth term. The sum of the first two terms means the first term is -half, the second term is 2. So sum of them, total up it together, it gives us 3 over 2. Yes, this is correct. Find the value of sum to infinity. So as we can see, this is our first term a, 1 over 2 power of 3, and then e power of 4 means it already times 1 over 2. This times 1 over 2. So common ratio is 1 over 2. To find sum to infinity, it will be a over 1 minus r. So 1 over 2 power 3 over 1 over 2. So 1 over 2 power 2 only. Therefore, we have 1 over 4. So here we have our option. Given that the sum of the n terms of arithmetic sequence is Sn, find Tn. So Tn in formula is Sn minus Sn minus 1. So first of all, we substitute our Sn, then we substitute our Sn minus 1. Sn, we substitute is, here we expand n squared plus n. So when I want to find Sn minus 1, so n will be, replace it as Sn minus 1. So it will become n minus 1 squared plus n minus 1. We expand that so that we can simplify. So expand this n squared minus 2n plus 1. Then minus n squared. Then this is negative n, negative, negative, positive n. Then 1 minus 1 is 0. Lastly, we can see n squared minus n squared. And we get 2n only. So here we have our option. Then state the values of the x where this expansion is valid. First of all, we look at the power here. 3 minus 6x, power of 1 over 2. Square root means power of 1 over 2. Power n equals to 1 over 2. This is type 2 formula. When we're having type 2 formula, we must start with value of 1. So this expression haven't simplified yet. We need to factorize the value of 3 so that we can start off value of 1. Then the value of 3 here will be power of 1 over 2 as it's factorized out from the bracket, which is having the square root. So when we divide 3 out, here we have our 2x. Now only we can read our star is equals to the terms that want to expand is negative 2x. To find its value, formula is modulus star less than 1. So modulus negative 2x less than 1. We simplify the negative. Modulus negative 1, modulus 2x. So modulus of negative 1, we get positive. Lastly, we get modulus 2x less than 1. Open the modulus 1, then insert negative out there. Divide by 2, so 1 over 2, negative half. So here we have our option. This is equal, so this is wrong. Here we have this. Which of the following is correct about this expansion? So first of all, we write the power first. 8 minus x, power of cube root. Cube root means power of 1 over 3. So when we're having n equals to 1 over 3, which is not positive integers, this is type 2. When we're dealing with type 2 expansion, our first term here must come with number 1. So therefore, 8 have to factorize out power of 1 over 3. When we take out 8, here is 1. When we here divide by 8, it will be 1 over 8x power of 1 over 3. Then 8 power of 1 over 3 is equals to 2. Now only we can start expand for this, where our star here, expansion here is negative 1 over 8x. So start our formula, 1 plus n star, then plus n minus 1, 2 factorial, star square. So we try to see whether which one is the correct last. N minus 1, n minus 2 over 3 factorial, star power of 3. So 1 is same. So this is wrong. This is an expansion using the correct star here. So the second term is negative 1 over 8x. So therefore, we can choose this as our option. So this is our final. Find the value of p given that your expansion is given here. So as we see, we have a power here 1. Okay, so our n here is p. Then our star here is 2x. So follow the formula, it will be 1 plus n star. So means here 2px will be equal to negative 4x. Therefore, 2p is equal to negative 4. P is equal to negative 2. So by using the term number 2, also we can find out the value of p. So that's all for this. Thank you for watching.